In this portion, we're going to be going over operations with matrices. Matrices have different sizes. Some of the sizes are going to be bigger, much smaller, but let's look at an example. Let's say if we have a matrix and we're going to say the matrix A is a 2 by 2. So that means that it's going to have 2 rows and 2 columns. That's going to be -1, 0, 2, and 1. And then matrix B is going to be equal to 1, -1, 3, and 2. The easy part with adding and subtracting matrices is that it is a very similar operation, and the only thing that you're going to check is that they have the same rows and the same columns. So in this case, if we say A plus B, the only thing you need to do is -1, and then you're also going to add the 1 because you need to make sure that they're coming from the same position. So the top left corner, and you add those 2, and then you're going to do bottom left, so 0, and then you're going to be getting the bottom left from the other one, and you get -1. Then we're going to do the top right, that's going to be 2 plus 3, and then we're going to do the bottom right, so 1 plus 2. So that will mean that we will get 0, -1, 5, and 3. So that will be your answer to A plus B. That's when you add both matrices. And if you're trying to subtract, it's going to be something very similar. So now we're going to do A minus B. So you're going to get -1. And now we're going to change all the signs to your B. So that's going to be -1. And then we have 0 minus -1. That's going to give you +1. Then you have 2 minus 3. And you have 1 minus 2. So now the answer to that operation is going to be -2, +1. Then we have -1, -1. So this is going to be A minus B. So be very careful, because in this case the order matters because you're going to be changing. But it's pretty straightforward. You're only going to be getting the same position, and you're going to be combining those numbers. So again, in this case you have a 2 by 2, so this is easy. Now let's see how matrix Z is going to be slightly different. So let's say we have A, and in this case it's going to be 8, 2, and -4. And then we have -1, 3, and 5. So in this case, we have a matrix that is going to be 3 rows and 2 columns. So this is going to be a 3 by 2. Again, 3 rows, 2 columns. And let's say matrix B is equal to 1, -1, 1, 6, -5, and 10. So when you're doing matrix addition, you're going to do the same thing as the previous example. You're going to just be careful with the position of each one. So the first one is top left, so we have 8 and 1, so we're going to add those 2, 8 plus 1. The next one is going to be 2 and -1. Then we have -4 and +1. So everything just came from the first 3 rows of each one. And then we're going to change this into -1 plus 6. The next one is 3 minus 5. And you have 5 plus 10. So the answer to this one is just going to be 9, 1, -3. And then you have -5, -2, and 15. So this is whenever you have a slightly different matrix. And this property also works when you have multiples. So if we say you have A is equal to 1, 2, and negative 3, then you have B is equal to negative 1, negative 1, and 2. And then we say C is equal to 0, 1, and 4. And if I tell you to just add A, B, and C, you only need to do 1 minus 1 plus 0, 2 minus 1 plus 1, and then we have negative 3 plus 2 plus 4. And that's going to give you 0, 2, and then we have 3. So this is going to be the answer to that. Now in this one, we have a matrix that is 2 by 3. So we have 2 rows and 3 columns. And in this case, we have 2 rows and 2 columns. If we were to add this matrix, we will try to end up with 2, 4, 1, 0, 0, negative 1. But the issue here is that you would do plus 0, plus 1, minus 1, and 3. But on this side, there's nothing for you to add. So whenever you have a matrix like that, we cannot add them. So we're going to say that they're undefined. Another property for matrix that we want to review is when we have multiplication. So if I say that matrix A is equal to 2, negative 2, 2, and then we have 2, 0, 1, 4, negative 1, and 2. And I tell you that what we're going to do is we're going to multiply by a scale factor. So let's say we multiply this by 3. So that means that we're going to get our matrix and we're going to multiply each term by 3. So we're going to rewrite the original matrix. And just so you can see the visual of that, that means that I'm going to do 3 times 2, 3 times negative 2, 3 times 2 again, 3 times 2, 3 times 0, 3 times 1, 3 times 4, 3 times negative 1, and 3 times 2. So that would give us 6, negative 6 and 6, 6, 0, 3, 12, negative 3, and 6. So that would be your answer to having 3 times matrix A. Multiply by a scale is actually very, very common, and you can use different properties for that. So let's say we have 3, and we're going to create parentheses, and we're going to say that we have matrix negative 2, 4. We get 0 and 1, and then we have 4, 3, negative 2, and 7. So when we have something like this, you can actually use a distributive property to send this to each part right here. So that means that you have 3, negative 2, 4, 0, 1, plus 3, 4, 3, negative 2, and 7. And then you just multiply that out. So that's going to be negative 6, 12, 0, 3, plus 12, 9, negative 6, and 21. And from this point on, the only thing that you need to do is add it. So you're going to end up with 6, then you're going to end up with 21, -6, and 24. So that would be the answer to our original problem right here, where we got two matrices that they're being added and you multiply it, and you will get the same answer if you were to add this matrix first and then you multiply. Now when you're multiplying matrices, that's slightly different. So for example, let's say we have a that is equal to -1, 4, and 5, and then you have on the second column 3, -2, and 0. B is going to be -3, -4, 2, and 1. So based on the property that we mentioned before, we know that A and B cannot be added because this is going to be a 3 by 2, and then this is a 2 by 2. So when you're adding, they need to look exactly the same. They need to have the same number of rows and the same number of columns. Now, when you're multiplying, that's not actually the case. So, for example, this is a 3 by 2, and then this is a 2 by 2. You need to make sure that the numbers in the middle match up. So in this case, you are able to multiply a 3 by 2 by a 2 by 2. So that, again, this number in the middle need to add up. So to get an idea, whenever you have a matrix, again, 3 by 2 and a 2 by 2, when you're multiplying those, we're going to ignore that. You just need to make sure that those numbers match, but your new matrix is going to be at 3 by 2. So the numbers outside the 3 and the 2 is going to tell you what the next size is going to be. So for a problem like this, if I tell you to multiply A and B, what you're going to do is -2, 4, 5, 3, -2, 0. And then we have, let's use a different color, we have -3, -4, 2, and 1. So when we multiply this, we're going to do, I want to copy everything from the first one, so just so you can see it. So we have the -1, the 4, and the 5. So what you're going to do now, though, is you're going to multiply the -3 times the 1, and then you're going to multiply that -3 times each one of, so you have -3, -3, and -3. Now, you are also going to multiply by the -4. All right, so you're going to get the second column and you're going to multiply by the second row. So the first row, first column is going to multiply by the first row, first column. The first row, second column for your first one is going to be multiplied by the second row of the first column, okay? So this is where it changes a little bit. It's going from horizontal to vertical, okay? So let me do a little arrow so you can see where the numbers are coming from. So that's going to give you +3, and then we're going to put -4. You're going to continue with the process. The next one is going to be -2. So let's do -2. And then you're going to add that -4. and then you're going to do 0 minus or times -4. So we're going to do plus 0 times -4. So that's just to get the first row. Now you need to continue with the second column. All right, now you're going to multiply the terms to find the next row. And to find the next row, we're going to get the first column right here. So we're going to use that column, and we're going to multiply it by the 2, and then we're going to multiply this column by the 1. Okay, so to do that one, we're going to do -1, and then we're going to multiply that by 2, and then we're going to do 4 times 2. Then you're going to do 5, and once again, times 2. The next one is going to be also plus 3 times 1 plus or minus 2 times 1, and then we're going to get plus 0 times 1. So we're multiplying everything by the second row, second column. And now this is just clean up all the numbers that we have. So this is going to be 3 minus 12. Then we have minus 12 plus 8. Then minus 15 plus 0. Negative 2 plus 3. 8 minus 2. 10 plus 0. So our answer to this problem is going to be -9, -4, -15, +1, +6, and +10. So this is the answer whenever you multiply those two matrices. In this case, we were able to multiply because you have a 3 by 2 and a 2 by 2. Now, if you were to swap the order, if you were to just change this and you decide to do B times A, that would not work because you will have a 2 by 2 and a 3 by 2. So in this case, these two numbers are not the same, so you cannot multiply those out.